Hey guys, so this is your first video on integration. So we're just going to do a quick intro on integration. So integration is the opposite of finding the derivative. So there's some notation stuff that you need to talk about. Let's just start with this example here. So what is the integral of 2x dx? So this symbol here means integration. So it just means, hello, I'm here to integrate you. And the dx just means I'm here to integrate all the x's. So these are just notation things. This is the actual function itself. So when I'm figuring out what the integral of 2x is, basically I need to think, okay, if 2x is the derivative, what was the original function, okay? Now there's several rules to help us with this. First, we're going to talk about real basic integrals. So if I have anything that is x to the n dx, so I have anything with an exponent, my integral is simply x to the n plus 1 divided by n plus 1, okay? So let's look at an actual example. So let's say the integral of x cubed dx. So the integral of x cubed dx is just x to the 4 divided by 4 plus c, of course. So you always have to do a plus c because when you're finding the derivative of something, the constant is 0. So when we're going the other way, I could have had a constant there, but I don't know because it would be a 0. So I always need to compensate for that by writing a plus c, okay? So this is the rule here when you have a polynomial function. So if you have a base with that is a variable and an exponent, this is the rule. You add 1 to the exponent and divide by the new exponent, okay? Then there's a few other rules that kind of like go all along with this. So if you have a dx, your integral is just ax plus c. Now this is kind of a version of this one, but let me show you what I mean by that. So I'm basically saying, what is the integral of 7 dx? Well, the integral of 7 dx is 7x plus c. I'm actually using this rule because when I have no variable here, it's like I have an x to the power of 0. So if I add 1 to the exponent and divide by the new exponent, I get x to the power of 1. Okay, so that is just a rule that you need to know about if you were finding the integral of a constant term, it's just 7x. Another good rule to know, and it'll help us maybe do this problem right here. If you have an integral of ax dx, it's the same thing as doing the as this. So any number that is a coefficient can be brought in and outside the integral sign. And why that's important to know is sometimes you could find the integral, but this number is kind of like messing it up. So you can just bring it inside or out. So I'm going to use this example right here. I feel like I'm doing a terrible job. I could bring this 2 outside, and then I just have x dx, and then I use my rule, which is to add 1 to the exponent and divide by the new exponent. Okay, so that is an example of just moving the coefficient in front of the integral sign. You can move it back and forth. That is allowed when we're doing integration. Another thing that we're allowed doing with integration, which you probably kind of already do, let's say you have the integral of 7x squared plus 5x dx. So this example just means, hello, I'm here to find the integral of this function in terms of x. Well, what you can do is just find the integral of each piece. Need a dx there. And then just add it together. So it's the same thing when I ask you to find the derivative of 2 polynomial functions added together. You simply find the derivative of one and find the derivative of the other. So this would be 7x cubed over 3 plus 5x squared over 2 plus c. You don't need the plus c twice. So whenever you're doing the integral of 2 things added or subtracted together, you can simply find the integral of each piece individually, okay? So that's kind of like how to find the integral of like the most basic polynomials. In the next video, we'll get into some more fun stuff.